Hello, this is Mr. Wallstrom. You've recently completed the describing motion assignment, which is shown here, and I thought we might take a little bit of time and go over the questions that were on it. The first question was to define motion. Motion is defined as any change in position. If you look at this picture here, you could tell that the dog has moved by comparing it to the bench and the object. I think it's a ball that's sitting on top of it. That object is called a point of reference. Why is a point of reference important when you try to understand or describe motion? A point of reference or a reference point is a known location that motion can be compared to. So if you use the bench as a point of reference, you can see that the dog is to the left of the bench in one picture and to the right in another picture, giving you evidence that it has moved or changed location. Describe a situation in which you are moving compared to one reference point, but not moving compared to a different reference point. I chose this picture of bumper cars here, and you might take a look at these two boys that are driving in the green bumper car. The driver and the passenger are not moving relative to one another. Their position is next to each other, yet they are moving compared to every other object in the room. They're moving compared to this car, they're moving compared to this post or whatever this is over here, and so forth. So you can be moving compared to one object, but not moving compared to a different reference point. The fourth question is, what is the difference between distance and displacement? Distance is the total length of the path an object in motion travels over. Take a look at this diagram down below of a park with a person walking through the park. You can see that they start over here and they walk, looks like sort of east along the lower edge of the park. In the next frame, they continue up, we'll call this north, along the right edge of the park, so they've traveled a distance of 40 meters here and 30 meters here, which is a total of 70 meters. Their displacement, however, is the straight line from the beginning point to the ending point, which you can see is 50 meters across the center. So, distance, the total length of motion. Displacement is the change in position in a straight line from the starting point to the ending point. If they walk all the way around the park and come back to where they started, their displacement will be zero, even though they have walked a distance of 140 meters. So you were asked in number 5 to write the mathematical formula for calculating speed. Speed is the rate at which position is changing over time. In mathematics, a rate is how rapidly something changes compared to time. Remember, rate is relative to time, so speed is calculated using the following equation. Distance divided by time. We abbreviate it over here as S is equal to D over T. Question 6. What key piece of information is included in the velocity of an object that is not given by its speed? Well, speed is the rate of change in distance over time, such as in meters per second or miles per hour, but velocity is speed in a given direction. Direction is the key piece of information. You calculate velocity by finding the speed, but you must also state the direction. As an example, a bird flying from Paxton Center School, located here, you can see the building, to Anna Maria College, which is up here, might be flying at a velocity of 10 meters per second to the northeast. This looks like it's roughly northeast. The last question, describe 2 different ways an object can change velocity. One would be to speed up or slow down. The other would be to change direction. So in this case, a child dropping an object, a ball, we know that objects, when they are dropped, speed up as they race towards the ground, going faster and faster and faster and faster, accelerating as a result. That's a change in velocity downward. On a Ferris wheel such as this, if you're riding in one of these cars, your direction is changing depending upon where the car is located. As you approach the top, you're kind of going sideways like this, whereas the car, as it's rotating down here, the velocity is downwards. So even though the Ferris wheel may spin at a constant speed, your direction is constantly changing because you're moving in a circle. Similarly, a ball tossed will change in both speed and direction constantly. The ball, as it rises, will be slowing down, but it will also be curving and eventually falling back to Earth. So instead of going upward, it's going downward. Direction is changing. And of course, as it falls downward, the speed increases as well. So this is a case where speed and direction are changing. The Ferris wheel is a case where the speed is constant, but the direction is changing. And the ball being dropped, speed is changing, but direction is constant. In each of these cases, it's a change in velocity. I hope that was helpful to you. Thank you very much, and now you can move on with the next part of your assignment today,